Now I'm going to go through a couple examples of the first type of factoring that we're going to talk about. We'll have several types that we're going to be looking at. This first type, we're going to be factoring out what's called the greatest common factor. So here, once I turn things the correct way, if I have 12x minus 18, I want to factor this, and I'm going to have two things that will multiply back to what we originally started with. But I'm going to leave them as two factors. And so what I'm looking for here is I'm looking for the largest number or expression that divides both 12x and negative 18. Well, this negative 18 doesn't have an x, so we won't be able to factor out any x's. But if we look and see, we know that there's a number that divides both 12 and negative 18. The largest number that divides both 12 and negative 18 is called the greatest common factor, and that's what we're going to be looking for. And so you should notice that the largest number that divides both 12 and negative 18 is 6. So we're going to go ahead and write that down. So once we have our greatest common factor, things get pretty simple. We're going to open up some parentheses here, and then we're going to divide each of the original terms by our greatest common factor. So I'm going to have 12x divided by 6, and then I'm going to have negative 18 divided by 6. Well, 12x divided by 6 is going to be 2x, and negative 18 divided by 6 is going to be negative 3. And this is our final answer. This is completely factored out because there's nothing that will divide both 2 and negative 3 in here. And if you double check your work mentally, if you go backwards, we do 6 times 2x, that gives us 12x, and 6 times negative 3 gives us 18. So this is our term that's factored out. So in this example here, we've got a few more x's, but we're really doing the same thing that we did in the last problem. Let's start just by finding the greatest common factor of our numbers. So we have 3, 27, and negative 9 that we're looking at. We're not worrying about the powers for the moment. We're just looking at the coefficients, the numbers in front. So 3, 27, and negative 9. Well, the largest number that can divide all of those is going to be 3. There you go. I'll make it a little darker for you. So 3 is our greatest common factor from the coefficients. Now I need to find the greatest common factor for our variable, for our x. Well, it's actually pretty simple. All we do is we look for the lowest power of x. So I've got x to the 5, x to the 4, and x squared. Since x squared is the lowest power of x, that's going to be our greatest common factor for our variable. So I'm going to put x squared out here behind that 3. So my greatest common factor is 3x squared. And as I did last time, I'm going to open up the parentheses now. And then I'm going to divide each of these terms in my original problem by my greatest common factor. So if you remember your dividing exponents, which is what we practiced at the beginning of the school year, we have 3 divided by 3, well that's 1. And then x to the 5th divided by x to the 2nd, we subtract our powers. And so I'm going to get x to the 3rd. Hopefully you can read that. I'm going to go on down the line. So 27 divided by 3 is 9. And then x to the 4th and x squared, I subtract my powers, 4 minus 2 gives me x squared. And lastly, negative 9 divided by 3 is negative 3. then x squared divided by x squared, 2 minus 2 is 0. So the x's go away, and I'm just left with -3. And this is my final answer.